Okay, good morning and welcome to our next unit, Chapter 3. Unfortunately, if you're not in class today, you will have to write this down on a piece of paper because I don't have any way of getting you a new packet. Or at least look at what we've got going on here, write down the definitions, the new definitions, and pay attention to the examples so that you know what to do. Our assignment that goes with this is actually out of the book today. So if you have your book with you, we're going to be on page 168 through 170. If you don't have it, go ahead and log on to the Savas Realize account, and you can find your book there and then just write down your answers on a piece of paper, and I'll get them when you get back. Okay, so our first lesson is going to be understanding relations and functions. And so the first thing to do is to do our vocabulary. So what is a relation? A relation is any set of ordered pairs. So we know what ordered pairs are. They look like this, x comma y. So here's an example. 2 comma 4 would be an ordered pair. This is your x value, this is your y value. And a relation is any set of those. Now, what we're going to talk about today is some of these relations are functions and some are not. So a function, to be a function, is where each input, meaning x value, is assigned exactly one output, one y value, okay? And so I'm going to show you what that means here in the examples. Okay, example 1, and you can find this in your book as well. I believe it's on page 168 or around there. Jonah's shipping 5 boxes to his uncle. Each box is the same size but a different weight. The cost to ship each box is shown. So down here, if it's 9 pounds, it costs $8.72. 8 pounds is $8.56, and so on. Okay, so organize this data as a relation. What that means is we just need to set these up as ordered pairs. For example, it would be 9 comma 872. And then 8 comma 856. I'm literally just putting this information in as ordered pairs. 14 comma 1003. 10 comma 901. And finally 12 comma 955. Okay, and so this right here is a relation. And so maybe we write this next to it. Okay, so this is your relation. All right, now it says organize the data in an arrow diagram. So an arrow diagram is very similar to setting it up like this, only you're going to make arrows. So your domain or your x values, this is called a domain, you list those in order. So what we want to do is 9, 8, 14, 10, and 12. And then our range or our y values, we list those. All right, 872, 856, 1003, 901, and then 955. And the arrow diagram is literally to draw an arrow for each one. So 9 goes with 872, 8 goes with 856, 14 goes with 1003. 10 goes with 901, and 12 goes with 955. Now, you're thinking to yourself probably, why would I do that? It's almost the exact same. Well, the reason is when we are going to start doing this below, sometimes these arrows get a little crazy, and we'll show you that in a minute. So it says, is this relation a function? What that means is, does every x value have one place it goes to? So, and it does. There's one for each one. So this is a function. So this is a function. And then what that means is, should Jonah expect the cost to ship a 15-pound box, which isn't in there, be a unique cost, meaning it will not be any of the costs already listed? And the answer is yes. And that's the definition of function, is that each x value gives you a unique y value. You can't have a 15-pound box that now costs $9.55 or something already taken. Okay, let's look again at what this means. So under the you try here, I have just a list of, and I'll slide this up, just a list of numbers, a relation that has no story attached to kind of show you. So it's asking, are these functions? Use an arrow diagram to help you explain. So what you do is you list the domain, which is your x values. All right, so we have a 1, a 3, a 2, and now we have another 3, but we do not list it again. Then we list the range, which is all our y values. We now have a 5, a 15, a 10, and a 20. And so now we do our arrow diagram. 1 maps to 5, 3 maps to 15, 2 maps to 10, and 3 maps to 20. So this is saying, is this one a function? What you're looking for here is, do each of your numbers in your domain have exactly one arrow shooting out of them? And this one, because of this 3 having 2 arrows coming out of it, this is not a function. Okay? In order for it to be a function, each one in the domain can only have 1 arrow pointing out of it. But the range can have as many as it wants coming out of that one. The y values can have all of them pointing to the same y. It's the domain that matters. Okay, so let's look. Turn the page if you've got it with you. Example 2 and 3 is what we're going to get through today. And example 2 is this. And this is also in your book if you're at home. Frank uses a table to record the ages and heights in inches of 6 students that he tutors. Is this relation a function? Explain. So again, here, this is a real life scenario. So these are kids that he tutors. Their ages 9, 10, 9, 8, 12, and 8. So those are all different kids, and this is how tall each of them are. Okay, so to set this up, here's our arrow diagram. Here's our domain. Our domain's all our x's. So we have 9, 10, we have another 9, but we won't list it again. We have an 8, we have a 12, and we have another 8. And then here's our range. Our heights are 54 inches. We have another 54, but we're not going to list it again. We've got 61, 45, 65, and 50. Okay, let's draw our arrows now. So 9 maps to, sorry about that, to 54. 10 also maps to 54. Now notice there are 2 arrows going to the same one in the range, but there's only 1 coming out of each. So far we're okay. That's a function. 9 maps to 61. All right, and now already we have 2 arrows coming out of one in the domain, so we know it's not going to be a function. But let's finish it. 8 maps to 45. 12 maps to 65, and then 8 maps to 50. Okay, and so the reason that this is not a function has nothing to do with the 2 arrows in the range going to the 54. What it has to do with is 2 arrows coming out of the 9 and 2 arrows. That means that 2 kids are 9 years old and they have different heights. 2 kids are 8 years old, they have different heights. This is not a function. Okay, and so I'm going to leave example 3, which again is in your book if you're at home, for you guys to do on your own or take a look at on your own. And what your homework is today is in that book is look at pages 168 through 170 and complete the questions in that section. Okay, if you have any questions, please feel free to email me and I will get back to you as soon as possible. Have a great rest of your day.